Hi all, welcome to Algorithms Made Easy. My name is Rajat and today we will be discussing the question best sightseeing pair. In this particular problem, we are given an integer array values where values I represents the values of the ith sightseeing spot. Two sightseeing spots I and j have a distance of j minus I between them. The score of a pair where I is less than j of a sightseeing spot is values of I plus values at j plus I minus j. That is the sum of the values of the sightseeing spots minus the distance between them. We need to return the maximum score of a pair of sightseeing spots. We are given the examples and we are given the constraints. We'll first try to decode what the problem is all about and how we can solve it. So we start off with the first example that is given to us. It is an integer array of length 5 and has some values at each of these indexes given. As index plays an important role in this particular problem, we'll show the index for each of these values as well. Now, what the question asks us to do, we need to find a sightseeing pair. For any given index, we need to find out the pair that is before this particular index, since j should be greater than I, and we try to find out what is the combined value of these sightseeing pairs. So if we take the 0th index as the pair for this particular index 2, we find out the value that it gives us is 8 plus 5 plus 0 minus 2, which is 11. Now what are these values? So the formula to calculate the sightseeing spot value is like this, which is value at I plus value of j plus I minus j. I being the index previous to the current index and j being the current index. So the values are 8, 5, 0, which is the index, 2, which is the current index. Similar to this, if we try to find out for index 1, pairing it with index 2, we get the answer as 5 using the same set of values like 5, 1, 1 and 2. For any given index, we have to search for its pair before this particular index. So for an index 3, for all the indexes before, which are 0, 1 and 2, we find out the value. Any given pair which gives us the maximum value, that particular maximum value becomes the answer that we need to return. So what are we trying to do over here? We're trying to solve this problem by computing each single pair and find out the maximum that we get from all these pairs. So by looking at the logic that we are following over here, we can find out what will be the time complexity and the space complexity as well. In any given problem, before even jumping to the coding part, we should know what is the time and space complexity that we are dealing with. The time complexity in this case, as we are iterating over the array 2 times in a nested loop, for every given index, we are searching for all the values from 0 to that particular index. So the time complexity becomes O of n square, and as we are not using any extra space during this computation, the space complexity in this particular case becomes O of 1. Now let us jump to the coding part of this brute force approach. Since this is a brute force approach, I'll be going ahead and solving the problem in one go. In this particular scenario, I is always greater than j. So over here, it's not I minus j, it becomes j minus I. So don't get confused in this. We run this, we get the answer. This might get submitted as well. Yeah, we got a TLE, and that's natural that we get TLE because the description that we have shows that it can go to 5 into 10 raised to power 4, so it's close to 10 raised to power 9. The time complexity would be n square. It is greater for this kind of constraints. Now time for the optimization. We need to figure out a way to find out the solution to the problem in a time complexity which is lower than n square. So let's start off from where we left and figure out a way how we can solve it in a more optimal fashion. For any of the given indexes, we're trying to find out what is the value or the pair that we can make of this sightseeing spot with the current spot. and we are trying to find out all these values along the way. So effectively, we are working for this particular index on all the indexes before this particular index. If you look at the equation given to us to find out the value of a sightseeing pair and rewrite it again, it will look like this, where the value of I plus values of j minus j. Now, we combined the values which are correlated with each other. Now, what these values signifies? Each one of these values, the first one is nothing but the current index, the jth index. It shows for the current index you have to subtract the index from the value, and on all the previous indexes you have to add the value and the index. Focus your attention on the bottom computations that we did, and we rewrite it again based on the formula that we have rewritten. It will become like this, wherein the value is 8 plus 0 plus 2 minus 3, 2 minus 3 being the current index value, and we similarly return the other as well. In this particular problem, if we take out the 2 minus 3 as a common, since it is common to all of the calculations, we find out it is nothing but the value plus index of all the previous indexes that we are trying to find out. So if for all the previous indexes we can find out what is the maximum value that we can get, then we can just add the current value, that is value of j minus j, into that particular max and find out the best sightseeing pair for the current index. So from all the three values that we have over here, 8 plus 0, that is the 0th index site, is the best pair for this particular index since it gives the highest value. Suppose we have a way to find out the maximum value from all the previous indexes, then there is no way we will need to compute all the previous indexes. The inner loop that we were doing from 0 to I can be removed just if we know the maximum value till the current index. If we use the same logic for another index, we find out that 6 minus 4 will be added. Now, out of these 4 values, what will be the maximum? It is 8 plus 0, which will give the best sightseeing pair. And for any index, if you do that, and if you already know what is the maximum index or maximum site that is giving the value to us, we can easily find out the solution. So this becomes the optimization part. Now let's take a fresh problem and try to solve it using the approach that we discussed. It's kind of a dry running the solution that we will be coding. We will be having a result for returning the final result for the best sightseeing pair. We would have the max, which will hold the value of the maximum sightseeing till the current index. Now we will start off from the 0th index. At this 0th index, since it's a sightseeing pair, we would need 2 sites, and 0th index alone cannot satisfy that particular condition. We'll simply make the max as 4 since it will be the starting point for us. We are putting the value 4 plus 0, which is 4, and putting that as the max directly. Now the actual logic starts. We are at the index 1. The value that this site has is 2 plus 1. We have to find out the max for all the previous values before this particular index. Now, what is result? Result in this case is nothing but max plus value of j minus j. Value of j minus j being the current index value and max being the maximum value from all the previous indexes. So if we put that into the equation, it becomes 4 plus 2 minus 1, which gives us 5. Since this particular value 5 is greater than the result, we put that into the result. Now the previous index includes the index 1 as well, and we try to find out what is the max that we can get. For 2 plus 1 gives 3, the max is 4. 3 is not greater than 4, so we won't put the max, we won't update the max, and we will move forward. We come to the index 2. The value that we can put it in the max is 5 plus 2, which is 7, but before that we'll try to find out what is the best suited pair for this particular index. So what is the maximum value that we can get from the previous indexes? It is 4. We already have that into a variable. We put that into the equation that we have, which is max plus value of j minus j. We get 4 plus 5 minus 2, which is 7. 7 is greater than the result, and we update the result. Now it's time to update the max. We get 5 plus 2 7. 7 was greater than 4. We updated the max now. We move to the next index. We again calculate the value, which is 7 plus 4 minus 3, which is 8. We have to update the 8. 4 plus 3 is still 7. So the max remains 7. We move to the next index. We calculate the value. We get the result updated to 9. The max gets updated to 10. We move. We calculate value. Results is still 9 because the sightseeing pair result that we got from the index 5 is still 9 only, and the max is not updated because it is still less than the max value, which is 9 right now. And we finally get to the last index wherein we do the computation. The result doesn't get updated because we get only 6 over here. The max is still 8 only, and the loop ends. Finally we get the result as 9. 9 is the maximum possible value that you can get from the sightseeing pair using these particular input. So to sum it up, what our basic intuition was that we don't need to calculate the previous values again and again. We tried to hold the max result in a variable so that we can use it again. We were updating it at each index after we have calculated the result. So when we are doing the update is important. We cannot update the max before we have updated the result. An index only becomes part of the previous index when we have already calculated the result for that particular index. So now it's time to code the particular approach that we talked about. Going by the logic, what do you think will be the time and space complexity? Since we have totally excluded the inner loop, the time complexity now comes down to O of n. And since we are not using any extra space here as well, the space complexity still remains O of 1. So this is an optimized solution. So now let's head back to the coding part. So we'll update this particular solution only. We needed a max variable and we will put the value of the 0th index directly into the max. We don't need this particular loop. We'll remove these. When we are updating the result, we talked about that the result is nothing but the max of result and the max value plus the current value minus the current index, and the max would be nothing but math.max of the max value and the current value plus its index. Since we have already taken into consideration I of 0, we'll start from index 1. Now we are done with the coding part. Let's try to run this code. So it ran successfully. Let's submit it. So it got submitted successfully as well. So in this video, we've seen how we can optimize a particular problem. We need to first go step by step by solving it first with a brute force, taking into consideration what the constraints are and what the time complexity and space complexity is expected of us. We cannot directly jump to the optimized solution. And once we are sure of what we are doing, it all makes sense that we in this case needed only the maximum value for all the previous indexes and we didn't need much more than that from the previous indexes. So I hope you do liked this video. Do let us know your thoughts, comments and queries in the comment section below. Thanks for watching. See you in the next one.